The title of this talk is Fast Car Need Fast Brakes. I guess that's the whole point in one sentence. In our industry, people, tend to go faster. They do want to do things faster, but nobody really talk about brakes. Nobody really talk about the safety mechanism that needs to be built around, getting it faster. And in this talk, I'm going to talk about how to build your safety mechanism when you're building your AI solution. Let's get started. Building safety tooling for risk-free AI tuning of Postgres. A little bit about myself. My name is Mohsin Ejaz. I've been in the industry for close to 2 decades now. I've been in DevOps, QA, and release management, mainly with Postgres. I've served most of my time with Enterprise DB. I specialize in CI/CD automation, database benchmarking, and QA and release management side of things. For the past 3 years, I've been serving as a senior DevOps engineer with DBtune, where I'm working as a benchmarking expert. I also serve with customer sale pre-sales activity, customer engagement. My main focus is reliability and performance with real world workloads. I regularly work with the customers on performance troubleshooting issues. Plus, I regularly give technical demos and and enabling. So that was like a little bit about myself. So yeah, let's talk about why we are here. So what's the promise? We have a lot of buzz related to AI, right? Everybody talks about AI. It's a next big thing. I will not say next big thing. It has been a big thing for quite some time now. But when you talk about AI based tuning, what's the promise? The promise is it can explore complex perimeter space really very quickly, like in very short amount of time. So if a human takes days or maybe multiple hours tuning, an automated AI solution can do it pretty very quickly. It can then in turn reduce your day-to-day activity of your specialist tuner, so he can do any other things. Plus it learns from your early sessions, so it is not like one time solution which you just build and it when you run it again, it will again have your heuristics. It will not take off thought about heuristics. It does learn from every session. So that's a promise which is very appealing. And in this fast paced world where things are very moving very fast, everybody is very busy. They are with people having multiple tools and multiple things. Productivity needs to be high. So this is a very what you call an engaging tool. But this comes about the fear part of things. What if AI picks a dangerous configuration? You're letting your AI touch your production system. It's like giving a log to your safe. And if you are passing a log to your important production system safe, you need to be the fear is that if what if it really destabilizes your performance? What if performance is degrading, not improving? What if something breaks while you're sleeping? These are all the questions that pops up into your mind when you're talking about AI, or when you're talking about giving keys to your production system. And in this talk, I'm just going to talk about the fear part of things, these things that one should actually ask, the question that people should ask when they let any AI solution touch your production system. So this basically is the promise and the fear side of things that one should needs to take care about. But before we go any further, let's first understand why this is actually hard and how we approached it, or if you are building your solution, how you can approach it as well. As you know, with PG18, Postgres 18, we have got like close to 400 parameters. Not all of them are performance related, and I believe we it's like couple dozen of them actually are related to performance. But it's not like that you simply copy paste one configuration and paste it to another and it works. It's a very complex problem. Why? Because they are interdependent. So parameters don't work in isolation. But what I mean with that is that if you change or if you touch one parameter, it can have a ripple effect or a butterfly effect in another parameters. So you should be aware of what you are doing, and that's why this problem is very hard. We have got many experienced DBA tackling this problem, and still, even with like decades of experience, they stumble upon a configuration or stumble upon a production issue that can you take them hours or even days in solving that. Plus, as I was saying, environment matters. So for example, a very quick example that I always want to give is related to JIT. As you know, with Postgres 12, JIT is enabled by default. And for complex queries, that's the right things to do. Postgres actually thought about it. They saw that, okay, people with analytical workload or complex queries workload, this can really benefit performance. But When you talk about RDS, what RDS did is that they disabled that. Why did they do that? They analyzed their customer workloads, and they realize that their customers are mostly OLTP. They're using OLTP workloads. So they disable that by default. So if you don't really know, or if you're just copying the configuration, so if you are running a workload which is actually very similar, nothing changes, and you just copy your self hosted configuration to RDS, it can actually be very harmful. And we have seen this in many production environment. People have actually reported it. There are many blogs around it. I'm not going to talk about this here much further because this is not a jet related talk. I'm just going to just sharing why this problem is hard. So that's the thing. That is why this is very complex, and AI based solution can really help you. That is why people are trying to solve this problem using AI. How we researched, how we approached it in our part of the world. We basically, tested it in many environments. We tested in variations. We tested in Aurora, RDS, GCP, Azure Flex Server, CNPG, Kubernetes environment, multi HA environments using Petroni, using EPAS, many folks, or any other, many variants that are in the market. And it tested very rigorously. We also tested using different workloads. We have tested with HammerDB, Benchbase, PGBench, and many other workloads. There is ClickHouse as well with their own workload as well, which we have recently tested as well. So the point here is, if you are building your own solution and if you're trying to create one, you have to take care of all those things, and you have to have this kind of mindset. You can obviously add in these situations, but my point is this: what how we did it in our part of the world. We try to do all those things, trying different benchmarks. We have in our in-house benchmarks. We test frequently, rigorously. Whenever we add any platform, we try to add all those things. The goal here is to understand what breaks and when and how to prevent it. So the idea of this talk was safety related, is actually safety related. So when you talk about safety, you need to first understand what actually breaks. So when it breaks, you then actually are able to fix it. So let's move on with this. In this small 25-minute session, I'm going to mainly discuss five challenges. I call it challenges. You can call it trap. You can call it whatever. I mean, whatever phrasing you can like. But for me, these are the challenges that we faced. One is obviously the main one, which is the memory problem. Memory is a very big constraint when it comes to tuning. If it's too high, it can cause an OM kill. If it's too low, it can be you're leaving performance on the table. Then their second task is related to exploration. So that is, I will not go further much here because there is a separate section around it. But cost, basically, exploration comes at a cost. If you spend too much time, it can actually degrade performance. Then there is a confidence problem. So whatever recommendation that you are giving, you need to be confident enough that it's actually valid or it's actually good. Then interaction problem. I briefly touched in my intro that parameters don't work in isolation. So that's a very big problem. And the final is actually blind trust. This is not a challenge, but obviously, if you're evaluating any new AI solution, you can't really trust blindly. That's also a challenge. You have to have a checklist that needs to pass and then only then you can actually trust them. So these are the five things that I'm going to go through in this session. So let's talk about challenge number one. The challenge number one is basically the very the most common one, which is basically memory. So before I go into it, this one, what is basically memory? As you know, we have got shared buffer, we have got work mem, we have got effective cache size, plus we have got max connections. As you know, every connection does hold a memory. Every query has every query operation has a memory bound to it. So this is a very big problem. This can easily get out of hand. So what I mean get out of hand is, I'm going to show a small example here. But what I'm trying to say is that if you don't have memory guardrails around it, if you're not taking care of the memory, that means just recommending a small change in your, if even a max connection type in your connection string or your work mem, things you can face an OM kill. And if that happens, your production systems can simply crash, and that's obviously not right. Right? So just to give you a small example here, what is the memory trap? So this is a very basic, we have seen this is a very basic RDS system with DBR6 4x large with 128 GB RAM. 128 GB RAM in a production system is pretty normal. And as you know, RDS comes with like by default 25% shared buffers. So shared buffers are set to 32 GB. Setting work mem to 64 MB on a production system is also pretty normal. Standalone, it's like a very basic thing. Nobody can actually, you can't really say that, okay, it's very high or very low. And uh, just, we have seen this. You have a query that has got a simple three operation query. When I say three operation, I mean it has like couple of hash joins, a simple index job, simple hash join and as SQL join, and that actually is a memory operation. And if on a production system you have your 500 concurrent user, that can easily translate into 128 GB. So you are already for a single query with 500 user connecting to your production system, you are getting into an OM kill. Now that's very dangerous. And now here I am not talking about any vacuum operation or any your headroom or any connection strings or anything like that. This is just from one single query. So that's how quickly, how immediately this can go all wrong. So that is why when you're building your solution, you have to have your memory guardrail around it. You need to know when you're recommending these memory related settings, you don't actually run into OM errors or any memory related errors. So how actually do that? What's the mechanism? It's very pretty simple, very basic. You have to actually check, you apply, and then reject. What I mean with that is you first have to calculate. So when it comes to calculation, this is mainly related to your workload detection. In our part of the world, we have a workload detection mechanism. That actually means when we see the workload, observe the workload, we know, okay, uh, what kind of workload we are dealing with, and that gives us our internal formula actually tells us that, okay, this type of memory search space will be good enough for this kind of workload. If you're building your own solution, you can have your threshold. We are setting our threshold around 80% or 85%. You can have it more aggressive or more conservative. You don't The point here is you don't want to leave performance on the table as well. You don't want to even recommend lower memory. You don't want to set memory work mem or any shared buffers or any memory related operation too low, so you are leaving the performance on the table. And the beauty of AI is that it actually learns from over time. So if there is any unsafe configuration that you have recommended, and if you are recorded it, if your mechanism is recording it, then you will not actually go there and again recommend it. So this is just a principle here which I am trying to convey, that you just take care of when you're building your solution. You have to have your memory guardrail and follow these checklists. So this was our first check. The second check is, exploration comes at a cost. So this is something related to, it's a maze. So if I explain it very simply, imagine you are in front of a if in front of a mountain, foggy mountain, and you don't know what's happening. You walk. It can be a pit or it can be a shortcut, so you don't know, but it doesn't mean you just don't go. You have to, if you want to cross the mountain, if you want to go to the end goal, you have to actually explore. But exploration comes at a cost at a time, y- which actually means there is a chance that you can fall into a pit, or you can, if that means that if you don't go there, it might not be a pit, it can be a shortcut. So you have to explore your search space. But how do you do that? I mean, what principles that you need to follow? Well, that's the thing that I'm going to explain. There are two things that I'm going to just explain here, but I hope that it's clear. It's a maze trying to find your it's navigating the maze, and it's trying to find your best solution and how to go there. So yeah, one mechanism is obviously performance regression detection. As I mentioned before, when it comes to memory, so this is going to be a pattern for all the challenges. You have to learn and you have to record, and that is where AI actually helps you. AI actually, you know, with AI, if you have built it properly, you learn from your mistakes and you record those mistakes, so you don't go there. So in the world of databases, you have got like many queries, right? So what we have seen is that mostly not every query is important for your workload. So if your workload has got thousands of query, there's a 80-20 rule that we follow, which basically means we follow the 80% of your query that are important. When I say important, whatever mechanism you follow, we follow at this point in time a runtime coverage mechanism, which is basically if your query is covering most of your workload, that is, we marked it as important, and then we just focus on that. So this is related to how you explore your search space. So if your search space is smart enough to detect what queries they are tracking, then that's a better approach. This is one of the things that you can do. You can have your own set of algorithm, or you can have your own set of rules behind it. But the point what I'm trying to make is you need to have a regression detection mechanism. If you don't have that, you will just be, falling into a pitfall or trying to explore the search space, which is not really important. At our part of the world, we have got fingerprint, which we call a fingerprint, which is basically top most important queries based on your workload. So we analyze the workload, we define what is important, and whatever it's what we feel is important for that workload, what query set is important for that workload, we just monitor that, and that is basically focusing your search space to that set of queries. So that's one thing. But here if you notice, I'm talking about performance, I'm talking about noticing, and I'm talking about your queries and then measuring the performance. But for how long? That's the latest part. Validation windows and threshold. So that's another important aspect. So if you are in a search space and if you monitor it for too short, that and in time it will be so maybe it was actually a shortcut that you just realize that initially for the first 30 seconds or 40 seconds you were there, you think, oh, it might be a pit, but it was actually a shortcut. That's a too short thing. But then if you think if you are there for a longer period of time, it can waste time. So you don't want to. Whole point of your solution is to be make it faster, right? So if it's not fast, it can cause too much issue, and if it's too short, it can again leave performance on the table. So having a proper threshold or a proper iteration window is very important. This is what I'm talking about, is basically your loop cycle. So you're testing your configurations, you're testing your data set. So, but testing it too long can cause an issue. Too short can also cause an issue. How we did it, we have, as I said, a mechanism to test a proper signal. So, if we have some mechanism where we are having the signal threshold. So, if the signal is stable enough and the threshold, if it reaches that threshold, only then we move forward. And we have obviously some time constraints around it as well, where we simply say that okay, if it is taking too long, we simply error out. So you have to have an error out mechanism as well. The third challenge that I want to talk about is obviously confidence problem. To explain it very simply, if I hit a bullseye right now, you will not start calling me Robin Hood. So what I mean with that, for me to be a good archer, I need to hit it consistently. So that's why statistic rigor is very important. That's the confidence problem. That means is that you can't really announce that your this configuration or these parameters are good without testing it again and again and again. So you need to make sure whatever you are recommending is actually valid and it's actually reproducible. So that's another challenge, that when you're building we're building your solution. How do you do that? You need to have multiple runs. One run is not enough. You need to have multiple, runs. You can have 5 or 10 or 30. In our part of the world, we do 30 iterations, and in 30 iterations, we have found it that for certain kind of workloads, 30 is like a good sweet spot where it is not too long or it's not too less. And during that 30 iterations, we have a statistic rigor maintenance where we validate the results, and we are confident enough that okay, this is the configuration that will actually give you constant results. There can be a bit of noise, there can be a 5% or 10% variation, but not much. So you need to have a reliable mechanism or a configuration mechanism where you can do that. So where can obviously be a bit of noise as well, but with your statistic rigor in place, this can actually reduce these things. Again, the another aspect of this is obviously having a rollback and mechanism. As I said, in the previous section of exploration comes at a side, you need to have your rollbacks in place. You need to have a mechanism where if if your configuration that you are actually recommending is not really valid, you have to have a rollback mechanism. You have to have a section where you are comparing to your previous configuration. If that was better, then you have to roll back immediately and go to the previous one. So you have to have this mechanism in place when you're recommending the configuration. This all ties into how you're building your solution, or how you are creating your uh, a solution here. And all this ties up with monitoring. Monitoring is one part where you can't make decision based on that. So what when you are building your tool, you need to have this. We have Grafana, we have Prometheus, we have like many other Delibo, and many other tools, pgstat statements and pgstat plans, which tells the plans and all those things. But when you're building an AI solution, you need to have these kind of things in front of you. You need to know your TPS, you need to know your query runtime, you need to actively monitor your memory, because you're making decision based on this. Plus, there are many disk related things. Your IOPS, you have got P30, P50 tires, you have got many limits and all those things. So all those things matter when it comes to these kind of things, right? So monitoring for safety is very important. The other challenge, which is actually our final challenge that I would talk about, is the interaction problem. I, I think about it as like tuning up the band. So if I start playing drums or a piano, it will probably, I'm not say probably, it will for sure be a noise. It will not be a music. So a good musician will obviously know how to tune it, how to tune up their band, how to, so it can be good to your ears. Whereas if I start playing, it will just be a noise and you will just kick me out of the room. So that's how the tuning is. It is like an interaction problem. If you tune one knob, if it's not properly tuned, it can just cause many issues. So it is important that you take care of all those things. And when you tune one thing, you should know, okay, what's the effect of the other parameters. As we have got very little time, I'm just going to share one production example. So this is one example which is very well reported in the blog. This is an astrophysics production system. What they did was they just disabled one parameter, which was enable sequential scan. They wanted to enforce index scan. They didn't know that it will inflate and their plan cost will change to 10 billion, which in turn enabled JIT. Now, the JIT threshold in Postgres is like, I believe, 100,000, but the plan inflated to 10 billion. This meant that JIT was enabled. Because JIT was enabled, the query runtime was from like 6 7 milliseconds, 6 seconds, 7 seconds, which is really what you call very off. And the solution was actually just changing the threshold, changing your statistic, updating your statistic, and changing that. So this was just from one parameter. They didn't know, they didn't do anything else. They just enforce index scan, and but enforcing index scans cause this ripple effect, the butterfly effect that I talk about. So it is very important that you know about the ripple effect and all those things. And you have to have a mechanism or understanding of parameters, how parameter interact with each other. You can read more about the blog that is mentioned here, Tim the Postgres JIT. This is again a JIT example, but it can be anything. Finally, your final challenge is obviously evaluating AI tuning solutions. So this is one of the most important thing, to be very honest. Blind trust. I talked in my initial slide, not trusting blindly to any solution that is asking this. So you need to ask these questions. If they don't have safety guardrails around it, if they don't have statistic rigor around it, if you don't ask, what happens when the failure comes, failure will happen, because we are exploring the search space. So it's not going to happen like, oh, there's not going to be any failure. There are going to be failure related to your performance. It can degrade your performance, or it can cause your memory issue. But there needs to be guardrails around it. If if a solution that you are evaluating doesn't have all those things, or if they are not recording all those things, if your rejected configurations are not being recorded or logged properly, then don't trust that solution. So you have to know what questions to ask. You have to ask these questions. You need to know how the memory is basically captured, how are the regressions detected, what happens when the failure actually happens. And if the solution is just saying just trust AI, or there is no monitoring tool, or there is no explanation or logging happening, then just don't hand over your keys to your safe, which is actually your production data, which is very important. So, what we learned today is basically the safety engineering pattern. Safety engineering obviously requires multiple layers. You have to monitor your resources. As I said before, you need to have your rejections recorded. You need to have your performance validated, and you need to have your statistic rigor. If you don't take care of all this, then when you're building a solution, then this is the blueprint. If you don't do this, miss any one of this point, then your solution that you're building will unfortunately be very faulty. So, what's the chunks of this talk? The chunks of this talk is that obviously design safety mechanism first. As I said, everybody wants to be fast, but when you want to be fast, you need to have, fast breaks. So always take care of safety first. This can in turn your solution to be fast, and you will be able to, get the results as soon as possible. So design safety mechanism first, and document and share what you learn. So community is very important. Community benefits and you learn more. What we have been doing in our part of the world, we have been very actively involved in community talks and community gatherings, and trying to discuss all those things. And we have seen, so few of these mechanism our solution has, improved is came from the community discussions and community talks that we have. Test failure first. Failures are important. So don't only work on the happy path. Try to test rigorously. Try to, push your benchmarks to a very unsafe place, and then build your safety solution around it. When you have your breaks faster, then rest assured your AI solution or whatever solution, the mechanism that you're building will be actually be very fast, and that's what we have seen. Uh, so the what is the key takeaway? Well, AI tuning needs safety engineering. The takeaway that for this talk is was basically, you need to have safety engineering, robust mechanism around it. AI can tune your database safely with the right safety mechanism around it. So if you don't have your safety mechanism, then AI can be very bad for you and it can actually harm. But if you have got your safety brakes on, then believe me, this can actually be very faster. So I guess we are at that end. Thank you so much. For any questions, pop your questions on our Discord channel, and thank you.